So this review from Google Classroom is going to look a lot like what you're going to see on the quiz. So the quiz tomorrow covers 3.1 to 3.3, so if you want to look at those notes, that's not a bad idea to do that. Let's take a moment and do some problems together. Now, I know that you know the shortcut. That's totally a thing. But I do want to, before we throw it out and never use it again, because you don't use it too much, if you could, let's practice doing the long way. Okay? So remember what you want to do when doing the long race. So what I always like to do is I like to calculate f of x plus h kind of to the side. And so we're going to plug x plus h into the function. Now, when we plug x plus h and we square it, remember you have to FOIL that. So you get x squared plus 2xh plus h squared. And then if there are any coefficients in front, you are going to need to distribute. So that's what you get initially for that f of x plus h. And I'm sorry, could you change that right there? That should be an h approaches 0. That's an h approaches. Okay, so let's plug in what we know. And I'm going to actually now do the distribution. So we're going to get 3x squared plus 6xh plus 3h squared minus 2x minus 2h. Now that's just your f of x plus h. And then remember, we are going to subtract f of x. So when you're subtracting an algebraic expression, you need to multiply everything by -1. Thank you. Okay. Oh, that's not a 3, that's a 2. Okay. So make sure that if you distribute the negative ahead of time, you distribute it to all pieces. So that's why this piece becomes negative and this piece becomes a positive. And then we're going to put it over. Now, usually at this point, there should be a nice amount of cancellation. So you'll notice that our 3x squared and our negative 3x squared cancel out. Our negative 2x has a positive 2x. And then every single thing there is divisible by h. So when we divide through by h, we get the limit as h approaches 0 of 6x plus 3h minus 2. Now, look back at your original function. From the shortcut method, we know that the answer should be 6x minus 2. Now, think about the fact at this point, if we plug in 0, the h term, this term goes away, and we get 6x minus 2. So you know the answer. You know the answer ahead of time. So at this point, check your work. If you did not get the derivative that you know what it is through the shortcuts, you did something wrong. So, this is a quick way to check your algebra. We know from the shortcut that the derivative is 6x minus 2. Now, if I ask you to show me the steps of the shortcut, if I say show me how you got that, what I want to see is this. I want to see that you took 3 times 2 and then x is 2 minus 1. And then this one is 2 times 1 and then x is 1 minus 1. So if you show me that, if I say, because I think there might be one where I say explain the shortcut. What did you do? Well, what happens? The power drops down in front, so show it. The power goes down by 1, show it. And then get your answer. If I think I did that, but I just want to make sure that you understand what the heck I'm talking about. Next, for C, it says find the slope of the tangent of f of x at x equals 1. Well, we know that the formula for the slope of the tangent is the first derivative. So we have a formula now that we can plug in any x we want. And so that is the point where an x value is going to be, where our x, you just replace it with a 1. And so now you just do the math. 6 times 1 is 6. 6 minus 2 is 4. So we know the slope of our tangent is 4. And you might notice that every single step is kind of building upon each other because the last thing says to find the equation of the tangent line at x equals 1. Well, we need to use the point slope formula. Sometimes they give you the point. Sometimes they just give you the x. So the first thing I would do is plug 1 back into the original equation, 3x squared minus 2x. So we get 3 times 1 minus 2, or 1. So we know that we're going through the point 1, 1. We're going to go through the point 1, 1. We're going to use the slope of 4. So now you're just going to do the point slope formula, y minus y1 equals m times x minus x1. So every place we see the y1 and the x1 is a 1 and the m is a 4. So y minus 1 equals 4 times x minus 1. Now I don't care, unless I specify, which I don't think I did, if you do anything more to that equation. That is the equation of the line. I know you know how to manipulate algebra. You don't have to go further. Any questions about our first problem that we see there? Okay. Now, here we're just going to do derivatives. I would like to give you a few different options because you get to decide how you do it. So let's start with 2a. 2a is just a polynomial. We can use our power rules, drop the power down in front, the power goes down by 1. And so our derivative here is 15x squared minus 4x plus 0. Now you don't have to write the plus 0. If you want to write the plus 0, go for it. Do whatever floats your boat. But remember, a derivative of a constant is just 0. Now, for 2b, I would do a rewrite of the original before I do any kind of derivative. Remember, square roots are 1/2 powers. Remember the rule. The main rule you want to remember is if you have a radical, you can rewrite that as a fractional exponent, and then you can do the power rule. So I would rewrite this as a fractional exponent n over m. If you don't see a 1, what happens to the square root? It's kind of deceiving a little bit. The power here is a 1. The index here is a 2. You don't really see those things. So that's why you get a 1/2 power. Cube root is a 1/3 power. Fourth root is a 1/4 power. Another thing you should do here is this 1 over x is the same as x to the negative 1. Now that we've done a rewrite to do the derivative, we can do it pretty quickly. You're just going to use the power rules. Be careful that when you do the power rules that you watch when you have fractions and negatives. And so the derivative of this one is going to be 6 times 1/2 is 3, and then x to the negative 1/2. And then the negative 1 comes down in front, so it's just a negative 1 in front, and then this becomes a negative 2. Now, I don't expect to rewrite, but I do want to talk about this because I noticed it might have been the worksheet yesterday, they mentioned don't leave anything with negative exponents. That is pretty common that we go one extra step for this. It's not completely necessary, but if we were, that puts the square root in the denominator. That puts this x squared in the denominator. So that's how you would rewrite it initially with positive exponents. I have seen some textbooks, they will rationalize any denominators that contain square roots. So some textbooks would go further. Now, I don't know if in your book, when you go to check your answers, if it does it, but I just want to remind you how that works. This is the same as 3 square root of x over x. So what happens is the square root pops to the top and leaves it just an x behind if you rationalize. So I just want you to see if you saw this, if you got this as an answer, the book might say that. So I just want you to have that perspective of how that works. Now, for C, we definitely need to rewrite the square root as a 1/2 power. Definite. But I would probably even take it further so that I could avoid the product rule. So if we just leave it like you see there in blue above it, we still are required to do the product rule, which is first times derivative of the second plus second times derivative of first. If you can avoid the product rule, if it's a simple, quick thing to do the product first and then just get a nice thing to do the derivative of, that's my suggestion. So if I were to do this problem, not for you guys, but just my own personal delight, if I were to do this problem, I would distribute. I would make this 6x cubed. 2 is 4/2, so when we add that to 1/2, that's 5/2, and then 10x squared. So I would do that, so I never had to do the product rule. So now I can just use my power rules, and so I can find the derivative very quickly. If you are a person that decides to do the product rule, that is perfectly correct. So you're welcome to. It doesn't hurt anything. What happens is if you do the product rule first, your derivative is kind of just your answer. You usually don't have to do much to the final answer. If you do the product rule, take the derivative that way, usually your simplification comes at the end instead of at the beginning. Which is better? Doesn't matter, yes.
Would it just be like 2x? Am I wrong? Because it's exponent of 2 times 1/2. Be 1? Am I wrong?
Oh, if the bases are alike and we're multiplying, add the exponents. So 2 plus 1/2, since 2 is 4/2 plus 1/2 is 5/2, the joy of fractions. If the bases are alike and you're multiplying, add the exponents, remember that. Okay, you multiply the front coefficients, but on the x's we add those. Okay, so now I'm going to take the derivative of that, so I don't have to do the product rule. And so my final derivative would be 18x squared. Now, 5/2 times 2, the 2's cancel, just leaving me a 5. And then the power goes down by 1. Now, how do we do that? Well, 5/2 minus 1 is 5/2 minus 2/2, or 3/2. I sometimes just think of subtracting the denominator from the top. So 2 minus 5, 2 from 5 is 3. And then the back one here, that's a minus 20. 3/2, I've seen where x to the 3/2, since that's 1/2, I've seen it written like this, x squared of x. Is that helpful? No, not at all. Am I okay with this as an answer? Go for it. Okay. Now, just like in D, if we do the product first, our derivative itself becomes a little easier. In C, we did the multiplication first, so we avoided the product rule. In D, since this is one term, we know from algebra how to do that division very nicely. So to avoid the quotient rule for D, we could divide first by that monomial, and then we have just a nicer thing to take the derivative of. If I can do my algebra up front, it does make the derivative easier on the back end. So I would probably divide it all by 3x squared. So we're going to get 2/3, and the x squareds cancel. We're going to get 5/3 x to the negative 1. We're going to get negative 7/3 x to the negative 2. Now, I do tend to throw my fractions, the 2 and the 3, the 5/3, the 7/3. I do tend to write it in front So I remember that that's the coefficient that's living there. I mean, is that the way you have to do it? No, I think it's just a way to kind of, that's my coefficient. That's what I'm going to multiply by. So when I do the derivative now, I don't have to use the quotient rule. When you take the quiz, if you do the quotient rule correctly, it's the correct answer. You can. It's not, we can avoid it. So if you can avoid it, avoid it. Okay, so if we do the derivative of this version, we get that the derivative of 2/3 is 0, so the constant goes away. The negative drops down in front, multiplies by the 5/3, the power goes down by 1. The negative 2 multiplies by the negative 7/3, making that a positive, and then the 2 is a whole number, so it multiplies by the 7 only on the top, and then my power goes down by 1. Now here's the thing, when I subtract 1 from negative 2, it becomes more negative, so it becomes negative 3. Now I'm totally okay, that's a final answer, I'm good with that, you don't have to do anything. If you were doing something like maybe checking in the back of the book, maybe it's a multiple choice question, you could go further and make that negative 5 over 3x squared and then positive 14 over 3x cubed. Do you have to do that step? No, not at all. But I want you to see that there are times where you'll see the answer written in that form, especially if they mention no negative exponents. Okay. Although E, we can do the product ahead of time and avoid the product rule completely. I do want to do one with the product rule and one with the quotient rule, just so that you have experience doing that. Now tomorrow on the quiz, if it doesn't specify, you do what occurs to your brain. Okay. So if we did the product rule, I'm going to call this one the first and that one the second. And sometimes I just put a little dot between them to remind me that I'm forced to use a product. That's a dot, that's a product, that's a multiplication. If I do the derivative that way, it's the first, as is, no changes, put it down, times the derivative of the second. Well, the derivative of that is 5x minus 12x squared. So this one, the x became, no, not 5x, I'm sorry, 5. This one, because of the fact that the x was there to the first power, when we do the derivative, x becomes a 0 power, and so there's no more x's. If you put x to the 0, that is correct, but you don't have to. And then we're going to have minus 12x squared, because the 7 is a constant, it goes away. And then plus the second as is in parentheses times the derivative of the first, which is 6x minus 4. Now, if you want to take the time to multiply all that junk out and combine like terms, go for it. But if you stop there, I'm okay with that too. That is the correct derivative. Okay. Now, the F, here, our final one, there is no way to effectively divide it correctly. You're never going to avoid the quotient rule for this one because the bottom never goes into the top evenly. So we do use the quotient rule. So here is our top, here is our bottom. So remember, the quotient rule is the bottom times the derivative of the top minus the top times the derivative of the bottom, all over the bottom squared. So make sure that you know those rules tomorrow. So we have to use the quotient rule here. The first step I think you should take is surround the top and the bottom with parentheses to remind you that you need to use parentheses in this process. Parentheses are really going to save you. You really need it. Okay, so let's do the derivative. So it's the bottom times the derivative of the top. Now the top is an x plus 1. When I take the derivative of x, I'll get 1 times x to the 0, which is 1. And then plus 1 goes away. And then minus the top times the derivative of the bottom. The only one that has an x is the 2x squared, so it becomes a 4x. And then all over the bottom square. Now, I do want you to do something for me in the quotient rule. I want you to leave the bottom. Please leave the bottom. But I want you to simplify the top. Okay? Leave the bottom, simplify the top, please. Okay? So let's practice actually doing that simplification. If we multiply those two together, we're just multiplying the first piece by 1, so that's 2x squared minus 3. Now, here's what I would do. Now, this doesn't mean it's the only way, but what occurs to my brain is I distribute the negative 4x. I kind of lump those two together to this thing. So distribute the negative 4x to both of those. There's other ways to do it, but that negative has to distribute in. So you would get negative 4x squared minus 4x. Again, we're simplifying the top, leaving the bottom. Now usually, not always, but many times, the top usually has some like terms at this point. Please combine like terms. Please write your answer in descending order. I know that that's not necessarily necessary. It's going to be helpful for some things we do later on. So your final answer would be negative 2x squared minus 4x minus 3 all over 2x squared minus 3 squared. Leave the bottom, simplify the top. Okay? So that's what your quiz is going to look like. It's set up very similar to what you see here. So this is a good place to study. You can get a blank copy back in Google Classroom. See if you can do it again. That's a great way to study math. If you can repeat the process, you're probably ready. If you can't, watch this video again. Look at some of the notes from before. You got any questions?